Good morning, Scouts. Today I'm going to show you the process of how I made this printed circuit board for the weather station. See, we got some copper lines that connect all the components together. I will show you one important lesson. This is the humidity sensor that comes with the weather station kit, and it is no longer functional because I plugged it in backwards, and components don't like that when you mix the positive and negative and get them backwards. They tend to get hot and burn out. So lessons learned. So this is a copper clad board. It's one-sided copper. You can get them in double-sided or multi-layer. To make things easy, I just picked a single-sided board. It's roughly 2 inches by 3 inches. And what I'll do is I got these thermal transfer sheets. Now they come in A4 size, which is almost, I don't remember the exact measurements, I think 10 by 8. And I cut them in half because I don't want to waste a whole sheet of paper. I got 10 sheets for $10, I think. And I designed my layout in a software called KiCad, K-I-C-A-D. And that will be a whole separate topic. But then I run it through a laser printer. So this paper is only good with laser printers, and it will lay out everything that we need to etch on the board. And then we have this black gooey stuff, which is called ferric chloride. And by the way, excuse the mess of my workbench. Doing some hand planing of ash, and I don't have enough room in my wood bucket to put all the scraps in to clean it off, and it's the middle of the night, so I don't want to wake everybody up by taking it outside. So I also have some water to rinse it off and a spray bottle with fresh water in. Paper towels. Parchment paper, which I'll use to put between a hot iron and the transfer paper and the PC board to keep the iron from sticking. Of course, gloves for safety. Although I may not put them on because it's hard to operate my tablet with gloves on. So, alright, so the first step is we need to transfer the image, this, onto the board. So I'm going to try to do this somehow without dropping the camera. So bear with me. So I'm going to try to clip this on my sweatshirt, and hopefully that'll work. Yeah, that may work. So I need to let me get a piece of parchment paper out first. And the parents out there are probably thinking, oh my God, he has a hot iron with all those wood shavings. Yes, I know. Shame on me, but I am really short on space. And I just dropped the parchment paper. Alright, so I need to line this up. And this only takes a couple minutes. And what I'll do, you gotta make sure it covers, lines up on the board so we don't have any of the pattern missing. And you know what? I have a piece of parchment paper there, and that's the problem. I forgot I ripped some off. I gotta put that directly on the board. And this is just a trick of trying to see through the paper so that everything is lined up with the parchment paper on, and it has to be on a good flat surface. So let me grab the iron. Again, I apologize for the poor video quality. And we're just going to sit that on there and let it heat up. Now once it's hot, you need to grab the spray bottle. Ugh. I'm going to put some pressure on it as well. I have done some trial and error on this because of course the paper came without instructions, but it's actually intended for like a roller press, but this actually does work pretty good. So I'll let it sit on here. The wiggling it back and forth and applying pressure, if I don't have the parchment paper, it'll move the transfer paper, and we don't want that. So and yes, I'm not doing this on a proper table. Again, I'm really short of room. I'm working on that. That's the ash that I'm planing down, I'm making into a proper woodworking bench. So I'll do a video on that as well. Although I'm not going to hand plane all of it. I'm going to run it through my planer because that's a lot of work. But that is actually from an ash tree that I cut down, a dead ash tree, and I'm cut it into strips. Interesting process there as well. So let me get it. This has an auto shut off, so I have to tilt it up every once in a while to turn it back on. Now you have to be careful with this because it does get really hot. I do, for those safety conscious, I do have a fire extinguisher right next to me. And again, I'm trying to keep this in focus, and I'm not doing too well of a job, but so what the copper board allows us to do, if you already have the weather station kit, or if you don't, I'll show you in a little bit. It comes with solderless breadboards, which you can put little wires, has holes in that you put wires in, so you don't have to do soldering. Problem with that is if you move it, the wires will come loose and you'll lose your circuit. Alright, so let me put the iron down. So, and I just shifted the paper. Actually, it is on the paper pretty good, so I'm going to spray it with some water because that helps it release. And I am hoping, now wait a second, spray it with a little more water. It helps cool everything down and transfer a little bit better. So hopefully I applied enough heat and I have everything lined up well enough. That's hot. So yeah, I just need to peel it back. So the important parts look like they're peeling off pretty good. These big black areas I put in just so I'm not eating a whole lot of copper off. There's no real reason for that other than it saves on the ferric chloride. It's not that that's expensive, but the more copper you etch off, the less performance you get out of it. Alright, so this is peeling off really good. I have a couple boards that I have to scrub off and do over because they didn't peel off very well. There, that turned out really good. And I threw a piece of parchment paper over so I can't see what I'm doing on my tablet. So yes, that turned out really good. So I'm going to unplug the iron because I don't need that now. And our next step is we're going to put it in the ferric chloride. Now before I do that, I want to top it off a little bit. I try only doing a little bit at a time, or a little bit out of the bottle. I don't want to put a whole lot in. It is light sensitive, so if you keep it in a clear container like this, it becomes less effective. And it says at the bottom, poison, corrosive. So I don't want to pour this down a sink because if I have copper Typically you don't have copper in your drain, but it'll corrode it. What I'll do when this is no longer any good is I'll have an old paint bucket, and I'll put it in there until it not dehydrates, until all the water out of it evaporates, and then I can safely throw it away. So this doesn't eat all the copper away quickly. It does work faster if you warm it up, but I don't want to put it in a microwave. I don't have a little heater to heat it. You don't want to put this stuff in a metal pan because it'll get corroded. So that's why I'm using this plastic. I probably could make a heater to warm it up out of the heaters for my 3D printer, but that's a project for another day. So we're just going to let that sit for a little bit. We do have to agitate it back and forth. When it eats the copper, that copper that's etched off lays kind of on top of the board, so that's why you need to agitate it. So I'll tease it some. Yeah. How's that for agitation? So this is what we're doing at. This is one of the first boards I designed, and it did not work as well as I wanted it to, so I came out with this design. And as you can see from this one, it's working pretty good. So when we do the workshop, we will be soldering a few of the parts on, not all of them. I'm going to pre-solder most of them on because I don't want to waste a lot of time soldering. That can be a tedious process unless you really know what you're doing. I can solder all the parts on this in about 20 minutes. The next step after doing this is I have to drill all the holes, and I'll use my drill press for that, and I'll show you that in a little bit. That's a tedious process as well because it's a really small drill bit, and I have to go really slow and make sure everything's lined up properly. Otherwise the parts don't fit in. I will probably fast forward this. I'll stop talking and do a little fast forwarding when I put this together before I put it on YouTube, so you're not watching me do this for 5 minutes. So as you can see, the copper's turning kind of a salmon color. That's that shiny layer being eaten off, and it will eat down until it gets to the fiberglass board. Anything that's under the black lines or black areas will not be eaten away. It's probably handy to have a pair of plastic forceps or something to pick it up. I'm using popsicle sticks because I have them, and I haven't found what I really should use, but they work. Kind of like chopsticks. So this is the solderless breadboard that I was talking to you about that comes with the weather station kit. The parts just plug in like that, and you hook wires up. We'll look at that more during the workshop. And this is one of the boards that did not transfer well. You can see down here a lot of the pads and lines did not transfer too good, so I have to scrub this off, and I can reuse it and then transfer over it again. This one did, and I already etched this one, so that's what it'll look like when it's done. Then I'll drill the holes, and then I'll clean it off really good, and then it's ready to solder. If I had tinning solution, I would put it in that first, and that'll tin all the copper, and that keeps the copper from getting corroded, and it will also allow us to solder a little better. If you can, I don't know how close I can get this without it getting out of focus, about there. The solder joints aren't that good because it's not tinned, so I may either get some tinning solution, or I found a way to make your own tinning solution. I might try that. So let's take a look and see how this is doing. The other thing you need to do with this stuff is wear eye protection, because if you get it in your eyes, it will burn. So you can see around the edges, right here, there's no copper left, so it's coming along pretty good. I'd say another 5 minutes. So again, I'm not wearing gloves, so I should, but I'm not because I have to run my tablet, and it's hard to do that with gloves on. Once I have the, that's hard to see. Once I have the holes drilled, I will transfer this onto the front side of the board, this side, and I'll have everything lined up so that we can tell where the parts go. There's nothing to etch on the top side, but it's a good way to do a kind of silk screen on the top side so you can see what parts go where. So we're going to check this again. Again, I apologize for the mess, but it is what it is. So we're doing pretty good there. I need to build a camera arm. I had one, but I have to fix it. So that's turned out pretty good. So probably a few more minutes. If we leave it in too long, it'll etch underneath the black, and then we won't have anything left to solder onto. So that would be an issue. Got a little piece of wood dust in there. Is that my rinse water? Yeah. I found some really nice old hand planes, and I've been trying for ages to figure out how to use them, and I finally realized I had to blade in backwards. Now they work really nice. I get these nice long shavings off, but it's hard work, but it's fun. I will, like I said, I'll do a video on that as well, because I just enjoy doing videos, and I'm trying to make a really nice woodworking bench with a vise and holes in it for bench dogs, which are a type of clamp for woodworking. In fact, if we do another, I need to find somebody that can make me some bench dogs. So if there's anybody that does I just lost my mind, lost my train of thought. Yeah, I need somebody to heat up some metal and form me a bench dog, so a couple bench dogs. So can't remember what that's called. Anyhow, let's take a look at this again. Yeah, we are almost done. I wish this camera had a zoom on it. Yeah, we're pretty close to being done, so I'm not going to pause it anymore. We'll just wait till it's done, and then we'll take it out and we'll put it in the water and rinse it off good. And then we'll let it dry, and once it's dry, and once I get the drill press cleaned off, because I was sanding and there's sawdust all over it, I will continue the video on drilling holes. So it'll probably be daylight by then. Hopefully I have a few minutes today during work that I can show it to you. And I'll try to find a way to mount my camera so you can see it. Alright, let's check it. It looks good, so I'm going to put that one underneath, put another one on top, do kind of like chopsticks. I'm going to hold it over the water. And rinse it off good. Try not to get everything on my bench wet. So, I feel good enough that I can hold it now. I'll just wash my hands really good. Just realized you're not seeing what I'm doing. So, there we have it. We have an etched PCB board. So, PCB stands for printed circuit board. And I'm looking, all the patterns look good, all our holes look good. So, a little bit messed up over here, but again, that was just a black area where I didn't want to etch all the copper off, so we all look pretty good. So I will stop this for now, and we'll pick up with the drilling of the holes. Alright, I have this mounted on the drill press, and this is the hard part because I got to get all the holes lined up just right, and it's a little time consuming. I also have a little airflow to blow the dust off so I can see what I'm doing. Because it's a fiberglass board, there should be a safety mask on when you do this. I can't talk when I do that, so I'm just gonna hope I'm not throwing too much dust up. Safety first, but we'll get through it. I'm probably not going to show you all the holes, but I'm just going to show you how it's done. That is a 1/32 drill bit. I have a really cheap drill press, so the bearings in it aren't as good as they should be, so I don't always get really good drills. I tried using a Dremel. That's really hard. If I had a stand for a drill press stand for the Dremel, that might probably be the best way to do it, but don't have one of those, so I don't really feel like building one either. I may do that eventually. Anyhow, so I have it on a piece of wood. I have to hold it. It has to be on a flat surface. I like drilling on a piece of wood because it just seems to work a little better. So bear with me, I'll show you a few holes. You have to take it easy with these tiny drill bits or they'll snap really easy. So you go slow, let the drill bit do its work. And there I got a first hole. I'll just move on to the next. So I know the camera's a little shaky. It's sitting on the platform of the drill press. So I do need to find a better way to mount everything. But for now it works. So we're just drilling straight through, nothing fancy. If this were a double-sided board, and I'll tell you the benefits of that is it's a little easier to run your patterns on it. The difficult part is you have to put the you have to put the stencil on one side, line everything up really well for the other side, and then etch it. So what might be easier to do is actually drill the holes before you etch so you can line it up easier, but then you run the risk of rubbing the black stuff off. The other idea is to drill some registration holes that are a little bit bigger, just to make lining everything up a little nicer. But we're only doing single-sided, so we don't have to worry about that. So that's how you drill holes. It'll probably take about 10 minutes to do the whole board. For computers and things like that, modern day electronics, that's all done by machine. So everything's done exact. And I'm sure if you are interested, you could search for a YouTube video on how they're made. In fact, I'm pretty sure the show How It's Made has done just that. Show you how printed circuit boards are made. So that's what I'm going to do right now. I will put this together and load it up on YouTube for anybody that's interested before the workshop. And we will do the next step in the workshop, which is soldering parts on. That's it for now. Have a good day.